We're going to pick up our lesson where we left off yesterday. So please take out or open up your Surface to the handout on 10 connections between limits and graphs. So again, we just finished explaining 7C, which was basically a cylinder minus a cone, which we calculated in part B. Here we go. On 10 connections between limits and graphs, let's see where we left off yesterday. It looks as though we had completed up through number 2. Did we get to number, oh, yeah. Oh, I remember, yes. We were learning how to draw muck diagrams. And so, as a warm-up today, I would like to check to see if you learned anything during that little mini lesson on drawing mini unit circle diagrams in order to solve trigonometric equations. So, what I'm going to do here is give you a sheet of paper. And on this sheet of paper, I'm going to ask you, so I can trigger and see it, and then this won't go in the grade book, so you don't have to worry about that. But I just want to do a little bit of an ungraded, well, unrecorded, but be a little formative assessment to see what your understanding level is. But on this sheet of paper, I'd like to show you the 3 types of muck diagrams, and I'll have you try one on your own. Okay, so one like we did yesterday, sine theta equals radical 3 over 2. We'll draw a muck diagram for that on this sheet of paper. In the middle column, it'll be cosine theta equals negative radical 2 over 2. And in the third column, just think of dividing this paper into 3 vertical columns. We're going to have tangent theta equals negative radical 3. There's a slightly different muck diagram for all 3 of these. So, like for example, let's construct them all simultaneously. The rim is the same for all 3 of them. It's just not that big of a circle. So like this. For a sine mini unit circle diagram, since the sine of an angle is the y-coordinate to the terminal point, we draw a little segment from -1 to 1 on the y-axis. For cosine, it's going to be a little portion of the x-axis. And for tangent, the muck diagrams are going to consist of tangent lines to the circle. The tangent line x equals 1 and x equals -1. But since it's mini, part of the mini aspect of this is that we don't have to label the axes. We're just doing like just the most basic sketch here. So we need 4 ticks. So for sine, since it's a positive value, we put tick marks without labeling with numbers, but at 0, 1/2. Do you remember what the decimal approximation for radical 2 over 2 is? Do you know roughly what that is? I mean, 1/2 is 0.5. What's radical 2 over 2? It's good to know. That's a 0.71. It's good to know that radical 2 over 2 is about 0.71, and radical 3 over 2, let's put this off the margin. Just, it deepens your number sense. Radical 3 over 2 is not a bad idea to know that that's about 0.87. So there's your 4 tick marks. Now for cosine, since it's negative, it's -1/2, negative radical 2 over 2, negative radical 3 over 2. Notice that's about 87% of the way between 0 and -1. Now for tangent, the key numbers for tangent on the friendly angles are radical 3 over 3 is about 0.58. If you ever type that into your calculator, you'll see it's about 0.58. Does anyone know what radical 3 is approximately? 1.6. Yeah, it's actually about, rounds up to about 1.7. So in terms of trivia, I mean, this is just trivia to remember this. Those are 4 good pieces of trivia to know for constructing muck diagrams. Gives you number sense. So, like for example, do you remember what the tangent of pi over 6 is?
3 over 3.
It's 3 over 3, so it's about 0.58. That means it's going to hit the tangent line about 0.58 of the way from 0 to 1. I mean, it's a unit circle, so the top of the circle is at 1. So it's 0.581 and 1.7. Remember, the dynamic aspect of this is, that's not the one I wanted. So the dynamic aspect goes like this. 0.58, 1, 1.7 are the decimal approximations of the tangent of pi over 6, pi over 4, pi over 3. So you can visualize the tangents of pi over 6, pi over 4, pi over 3. I mean, you want to say goodbye to SOHCAHTOA, not be doing opposite over adjacent all day long. Opposite over adjacent. When you say goodbye to SOHCAHTOA and say hello to unit circle-based definitions of sine, cosine, and tangent, you see that the tangent of an angle is the y-coordinate of the terminal point divided by the x-coordinate of the terminal point. That works even in quadrant 2 and 3. I mean, technically, SOHCAHTOA only works for right angles, for acute angles. So, SOHCAHTOA, it was great knowing you, but you were kind of restrictive, and we need to move on. We need to move on. Goodbye, SOHCAHTOA. Hello, unit circle-based definitions of sine, cosine, and tangent. So, there will be, in these tangent mug diagrams, instead of 4 ticks, there'll be 8 ticks. So its tangent is a positive number. You'll have these 4, and then negative 0.58. Negative 1 is even with the bottom of the circle. So those would be the 8 tick marks on a tangent mug diagram. If, like we have here, tangent is a negative, then you would use these 8 tick marks. 1, 2, 3, 4, 6, negative 0.58, negative 1, negative 1.7, positive 0.58, or rather, negative 0.58, negative 1, negative 1.7. Why? What's going on here? Well, if someone ever asks you to visualize the tangent of 5 pi over 6, you can say, well, 5 pi over 6 is, in fact, tell me when to stop when my terminal ray has rotated through an angle of 5 pi over 6.
Stop.
Yeah, I was hoping you said it would stop right there. Stop. For any point on the terminal ray for angle 5 pi over 6, the tangent of the angle is the y-coordinate of the point divided by the x-coordinate of the point. Notice how the x-coordinate of the point is negative 1, because this is the tangent line, x equals negative 1. And the y-coordinate is about 0.58. So y over x, 0.58, or radical 3 over 3, divided by negative 1, is negative radical 3 over 3. So these are positive values, essentially, negative tangent values, positive, and then negative. But when it comes to, so those are the 3 types of mug diagrams. So you set up the rim with the tick marks. So here, I'll finish the tangent one, just the sine one. Radical 3 over 2, tangent for a rim point there. Think of a terminal ray gun. It's like it sounds really dangerous, but it's like it shoots out a terminal ray to those 2 points. Now you have a visual representation of all the angles. You've sine is radical 3 over 2. Would you please complete the mug diagram for this middle one? Put the axis point on the correct tick. Then locate your terminal points so that you can shoot those terminal rays through the rim points. Well, the rim points are really terminal points. Okay, so I think it goes on this one right here. I think that's where negative radical 2 over 2 is. So, Sam, would you be willing to come to the board and draw a perpendicular dotted line through that axis point, through the right axis point? Just draw a perpendicular dotted line. And then put points on the rim wherever that is. Now hand the stylus on to a young lady who will then draw terminal rays that pass through. So this is Madison coming forward. And would you please switch over to yellow on the palette? So just click yellow and see other hand.
Oh, sorry.
Well, you have no way of knowing because it's your first time. So starting from the origin, go ahead and draw the 2 terminal rays. Yeah, that's the origin. That's 0. That's one of them. So there's your mug diagram for that one. Thank you. It's well done. Any questions on how to get the mug diagram that represents all of the that depicts all angles theta whose cosine is negative radical 2 over 2? Now for a tangent mug diagram, remember you're thinking 0.5811. So that's negative 1.7. So there's a couple of points here. There's negative 1.7 is the ratio of y to x here, and negative 1.7 is the ratio of y to x there. Those are the two tangent points, if you will. So then we go back, turn on the terminal ray gun, just kind of gets warmed up. It's warmed up down. It's all very dramatic as those terminal rays shoot out from the origin. So now we have depictions, putting the G in vegan tomorrow. We have graphical representations of all the angles that make that equation true. So now we can write out solution sets. Here, I'll write one. I'll write one. This one would have to be, since I haven't restricted it from like 0 to 2 pi, if I said, well, find the solutions over the interval 0 to 2 pi, well, then you would have said, oh, there it is, pi over 3, 2 pi over 3. But I didn't restrict it, so you got to find all of them. You got to say theta is an element of the set. That's pi over 3. You can eyeball it, plus 2 pi k. Someone asked yesterday, isn't it plus or minus 2 pi k? Well, no, we're going to define k. See, letters of the alphabet don't have inherent meaning. They're not born with meaning. They have to be given meaning by people who use let statements. We have to attach meaning to symbols with words. X doesn't mean anything unless you say it's a real variable. K doesn't mean an integer or n or anything. Doesn't mean anything unless a person attaches meaning to it with words. 2 pi over 3 plus 2 pi k, and then we say for all k that are elements of the set. What letter of the alphabet in this context is assigned to the set of integers? Which letter is it? It's actually Z. So, well, Z represents the integers in the context of set notation. So that's planet-wide. So that's a convention, it's agreed upon. Here, go ahead and try to write the solution set for this one. Write out the solution set that corresponds to the Mach diagram. Right. Charlie, would you be willing to pronounce the first part of it, starting with theta? Well, like for example, if I were asking you to pronounce the first part of this, actually the first part in the top line, you would say theta is an element of the set pi over 3 plus 2 pi k. That's just the first layer, not the second layer. Can you give me the first layer, starting with theta for this one?
Theta is an element of
Say of the set.
Of the set.
Well, now, what angle is this? What angle is this that has a cosine of negative radical 2 over 2? 3 pi over 4. So, keep going.
Plus 2 pi k.
Okay, so that's the first layer of coterminal solutions. Then what's the next layer? Help me out with that, please. Ellen.
The next would be 5 pi over 4 plus 2 pi k.
And then pronounce this last piece here for me. Linda, would you be willing to pronounce what essentially amounts to this? Say, that are elements of. You know, just say that one more time, just to pray. Because if those words are flowing off your lips, then it'll help flow through your mind. No, let me just grab the door. So we're basically just putting the V in vegan tomorrow. We're getting connected to the solution verbally. So starting with for all. I just want to make sure you got it, because there's no point in this being confusing. See, the set of. Then you know what the last word is? It's integers. Go ahead and say that word. Class, let's all say this together. When I say go, I'd like all of you to say out loud and in unison, for all k that are elements of the set of integers. Just follow the bouncing math teacher's Promethean stylus. Ready? Go.
For all k that are elements of the set of integers.
Yeah, It's important you know they're integers because that means that one of the many solutions is found by letting k equal 5, because 5 is an integer. 3 pi over 4 plus 2 pi times 5. What would that be? That would be 3 pi over 4 plus 5 full circles. 1, 2, 3, 4, 5. So when k is equal to the integer 5, sure enough, we have a terminal ray that is coterminal with this one. So it's important to be able to say what those symbols represent so that you understand the concept. If you haven't already, go ahead and write down all of the solutions depicted in this third mock diagram. Write the whole thing. Pause the camera while you're working. I hope you came up with interpreting this theta. In fact, the nice thing is you can take a shortcut. You don't have to write 2 layers because they happen to be pi apart from each other. I mean, you can, this is a special case. We've got this angle, which is 2 pi over 3, plus pi takes you here. Oops. Back in the day, I used to have an undo command. Been a few years since that worked. Okay, so let's try this again. 2 pi over 3 plus pi plus pi plus pi. Unlike those other ones, which were not all separated from each other by an increment of pi, these are all just pi apart from each other. So we have the option of doing the shortcut and saying theta is an element of the set 2 pi over 3 plus pi k. For all k elements of the set of integers. I mean, that's the most compact representation. But if you like doing 2 layers, then you would also get full credit for saying theta is an element of the set 2 pi over 3 plus 2 pi k. And what's this angle down here? 5 pi over 3 plus 2 pi k for all k that are elements of the set of integers. You can do the green one or the red one, doesn't matter, both full credit. Any questions on that? Okay, so now turn this over. I want you to do it on your own. So this is the formative assessment. Here we go. Draw a muck diagram and write the full solution set for cosine theta equals 1/2. Yeah. I'm just going to tour the room to see what muck diagrams are appearing on your sheet of paper. You draw that perpendicular line, there should be a clearly visible, I call it CVAP. Clearly visible axis point. Okay. And the perpendicular. Yeah, that's a CVAP. That's clearly visible axis point. So put a CVAP. Okay, class, when I say CVAP, that's clearly visible axis point. That's this thing here in red. It's got to be clearly visible because that shows a connection. That shows that you understand that the cosine of an angle is an x coordinate of the terminal point. So you have to have that clearly visible. Your muck diagram has to have a rim, an axis, 4 ticks or sometimes 8 ticks if it's tangent, a clearly visible axis point, a perpendicular dashed line, 2 terminal points, and 2 terminal rays. Those are the required features of a muck diagram, okay? They've all got to be there. Some of you were missing the CVAP, the clearly visible axis point, but here's the perpendicular dashed line, the 2 terminal points, the 2 terminal rays. There it is. So what's the complete solution set for this one? Would you help me out on this one, please? Paul, go ahead. starting with theta.
Theta is the element of pi over 3.
Say of the set.
Theta is the element of the set of pi over 3 plus 2 pi k and 5 pi over 3 plus 2 pi k for all k, the element of the set of integers.
Use plural on element, that are elements of, for all k that are elements of the set of integers. Okay, solid. Thank you, Paul. Any questions on that? So, go and put your name on that. Then hand it up to me. If you, like, you know, if I were you, I would take a picture of that before you. Just take a quick picture of both sides of that, either with your Surface or with your phone, because there will be 2 muck diagram questions on the homework that's due tomorrow. You'll have to do 2 of these on the homework.
Oh.
Yeah.
Okay, so for the homework, is it 1.2?
It's 1.2 is due.
Just 1.2.
Just 1.2, that's it. So as soon as you're done, you just go ahead and put them right here, make sure your name's on it. Strongly recommend you take a picture before you turn it in. Okay, now, part of the homework that's due tomorrow, I want you to know right now, what are the 2 muck diagram problems you have to do? One of them is the equation sine x equals -1/2 over the intervals 0 to 2 pi. Just so you know, this is teacher example number 1. So sine x equals -1/2 over the restricted interval 0 to 2 pi, which means you won't have to do for all k elements of the set of integers. And the other one that I'd like to do is cosine x equals radical 2 over 2. Those are 2 that I'd like you to add to the homework. In case you're wondering, well, where do I go to find out what the rest of the homework questions are? I just want to make sure that's clear on the website where it is you go. So if we go to calculus topics, let's take a look at general resources. In general resources, you see homework assignments for all of semester 1. And notice at the top, it says, when you see a green asterisk next to the problem, like on 1.2, looks like there aren't any green asterisk problems. There are in 1.3, but okay, so it says, notice here where it says solve 2 trig equations, and not teacher example, it's trig equations. TE is trig equations. Those are the 2 I just announced to you. They're to be announced in class. I just announced them, so you got those. So your homework is on page 59 of your book to do these examples, and on page 71 to do those. All of the solutions are already posted online. I would recommend that you do 1 homework question at a time as you're getting used to this so that you don't get overwhelmed. So as you're doing the homework that's due tomorrow, I'll put an online submission. It's online submission. But here's my recommendation to you. Open up the solution so you have them right there in front of you. I trust you to be responsible with this and to not mindlessly copy the solutions. I know you're not going to do that. You wouldn't be here if that's what you're up to. But like problem 1, write a brief description of the meaning of the notation limit as x approaches a of f of x equals 25. Do your best and then take a look at the answer and see if you got it. And then go on to the next one. Just do 1 at a time. Because I don't want you to be spending hours doing the homework. If you're going to be frustrated, just be frustrated for a short amount of time and then look at the solutions and see if you're up to speed. Because you'll get it. You'll get it based on just being here in class and all the work that you've already done on mathematics over the years. You'll be okay. Just take it 1 problem at a time. All right, so now, do you have any questions as to where to find the homework problems and how to proceed with using the solution sheet in a responsible way? We okay on that?
Can we see the teacher examples?
Yeah, the teacher examples, you know what, they're already posted. I mean they're on the solutions, so you can just take a look at those on the solutions. Okay, so now let's wrap those last pages of the 10 connections packet. So, okay, we're on this page, and it says what's the limit as x approaches 0 of f of x? Well, since a limit is an output value, this is one of those situations where, you know, the point 0, 0 is on the graph. So what is the limit as x approaches 0 of f of x, friends? I haven't heard it yet. This is the x-axis, and that's the y-axis. Here's the line, horizontal line, y equals 2. Here's a vertical line, x equals -4. It's the same graph as on page 1. So friends, what is the limit as x approaches 0 of f of x? It's gotta be 0. It's based on the y coordinate of the point on the graph. So we say the limit is 0. And you might have noticed that on your homework, you are required to state the graphical significance for every limit that you do on page 71. So every time you do a problem on page 71, after your answer, write a graphical significance statement, right? The limit is blank and the graph blank, just like we're doing here in class. So it's required on homework, so back to this, we got the limit is 0, and there's nothing fancy going on, it's just a point on the graph, it's continuous. And the graph is continuous at 0, 0. If you're wondering, where did you come up with that, Mr. Royce? Look, it's one of the templates. Check at the bottom of page 1, I used template 9. The graph is continuous at that point. Any questions on page 3 of our handout? 1, 2, so we're on page 3. Let's go to page 4. Suddenly we're on page 4, which hopefully looks something like this. All right, please try problem 4 on your own. Okay, class, just time out real quick. There is a question from a previous problem. I want to make sure this gets resolved. The question has to do with why did we pick odd when we said that the limit does not exist in the graph as an odd vertical asymptote x equals -4. One detail, this is, I look way back at college algebra, but in the vicinity of an even vertical asymptote, the graph will behave either like this or like that. In the vicinity of an odd vertical asymptote, the graph behaves either like this. So that's how you can classify those as either even or odd vertical asymptotes. So if you're at the football game, where they're having the big dance, the neon dance, you're not sure what to do, you can go try to freak people out, go even, odd, pull a head back, even, odd. People would be like, wow, this is how you do the neon dance. No, it's just even vertical asymptote. Okay, just done. That's my advice for how to succeed in the Wheaton Academy Social Scene. Now, I hope that on number 4, you said, let's go right to the statement. I'm gonna skip to the statement. I'm gonna say the limit is 7. It's a two-sided limit, so the limit from the left is 7, the limit from the right is 7, and the graph has a hole at 4, 7. And the graph has a hole at 4, 7. Notice the connection between the limit and the graph is that the limit is the y coordinate of the hole. This happens a lot. Any questions on that one? The limit is connected to the graph. Now, please try number 5. Oh, one of the templates is invalid because we never use it. It's just never valid. That is number 8, just cross it off. Never use it for 8. Because the limit has nothing to do with that point that shows up on this problem. You would never care about -3. Here we say the limit is 8 and the graph has a hole at 5, 8. That's the end of the story. We don't say, and there's a point at 5, -3, because that point doesn't tell you anything about the limit as x approaches 5. That tells you what f of 5 is. Yeah, f of 5 is -3. You have to train your mind to ignore f of 5 when you're dealing with the question, what is the limit as x approaches 5? From the left and the right. From the left and the right, let's say. So, giving that whole statement, I said it, but I want you to say it in your words that you've invented on your own and defined, words that no one's ever heard before. No, these same words I said. So let's go to, okay, Charlie, you're on. starting with the limit
Oh, for the top 5.
for number 5.
The second part or the first part?
The whole thing starting with the limit.
The limit as x approaches 5.
No, all you have to say is the limit is.
The limit is as x approaches 5 f of x.
No, all you have to say is the limit is
Just
x.
say
In
the limit
fact,
is,
here,
and then-
in case you forget, I've given you the template. All of these are gonna follow the template, which is right here.
I want you to read
The limit is,
the answer.
yeah, so read the statement. I think I know what you're thinking. You were kind of like doing part A, but the first part of it where you just say what the limit is. And that's kind of like what we did yesterday, but now all I want you to do is give me the statement, 5.2. 5.2, go for it.
The graph is a whole at 5, 8. Answer that.
Actually, say the whole statement starting with the limit.
The limit is 8 and the graph is a whole at 5, 8.
Yes, the limit is 8 and the graph has a hole at 5, 8, in parentheses, 5, 8. Do you have any questions on number 5? We okay on this? So far, give me fist to 5, where fist means 0 understanding of what's going on so far. All the way up to 5 would be a high level of understanding. You don't have to put way up for everyone to see, just so I can see. Ready, fist to 5, go. So I'm not seeing any zeros, maybe a 4.5 or 2 there. Now, this one requires some real attention to detail. Limit as x approaches 3. If it had said the limit as x approaches 3 from the right, then I would say the limit is 6. The limit is 6, and the graph has an endpoint at 3, 6. But since it doesn't say from the right, if it had said from the left, or as it is, I mean, the limit as x approaches 3 from the right is 6. There's no train track over here. The locomotive can't approach. So the limit as x approaches 3 from the left does not exist. Therefore, the two-sided limit does not exist. And so we say the limit does not exist. The limit does not exist. And the graph has an endpoint at 3, 6. And number 7. Raise your hand if you think you know what the limit as x approaches 3 is, or at least the statement. Let's skip right down to 7.2, the statement. The limit blank and the graph blank. Who'd like to give that a go? Linda, do you want to try that one? Yeah, try it.
The limit does not exist.
Good.
And the graph has an odd vertical axis.
And then, actually, this one is even, so it's even.
Yeah, sorry.
Odd.
Yeah, I wrote even, but I don't know why I said odd.
Let's all try it again, shall we? It goes like this, it goes even. Ready, go. Even, say, odd. Even, no, and even goes like this, even, odd. Even goes to the even. It's pretty good. On odd. The limit does not exist, and the graph has an even vertical asymptote at x equals 3. Let's turn the page. Next page, number 8. Okay, so if we said the limit as x approaches 9 from the right, the answer would have been 4. If we had said the limit as x approaches 9 from the left, what would the limit have been? 3. But since it's the limit as x approaches 9 from both sides, that means we have to look at the limit as x approaches 9 from the right, which is 4, the limit as x approaches 9 from the left, which is 3. Since 4 does not equal 3, the limit does not exist. So we say the limit does not exist, and the graph has a jump from, and you can go either 9.4 to 9.3 or 9.3 to 9.4, doesn't matter, from 9.3 to 9.4. Now, on number 9, is, that's a special case that you're not really gonna have to deal with. We would say, the limit does not exist, the graph has a parabolic asymptote. What's more important for the limited time that we have left here is to go to, what if they don't give you the graph? Well, here, to find the limit as x approaches 8, now, at -8, there's a vertical asymptote, but at +8, there's nothing fancy going on, it's just continuous. So 5 times 8 is 40 over 16, that reduces to 20 over 8, 10 over 4, 5 over 2. We just say, without even sketching the graph, we can say the limit is 5/2. And the graph is continuous at the point, even though we didn't take the time to sketch the graph, we know the point at which it's continuous is 8, 5/2. That's the x coordinate. A limit is a y value or an output value. Now you can't do that on number 2 because when you plug a 4 in for x, you have division by 0. So we use an algebraic technique. We're putting the a in vegan tomorrow. Instead of doing it graphically, we're doing it algebraically. So we factor. It's called factor and cancel. So we're going to take the limit as x approaches 4. The numerator does factor into x minus 4 times x plus 6. But the fact that the x minus 4's cancel are a signal that the graph contains a whole whose x coordinate is 4. So we can say the limit is 10, right? Because after we cancel, we put 4 in for x, we get 10. The limit is 10. And without even taking the time to sketch the graph, we know that the graph has a hole at 4, 10. Now, limits at infinity. This is a nice review of college algebra because do you remember how every rational function is either top-heavy, balanced, or bottom-heavy? And if it's bottom-heavy, the horizontal asymptote at infinity is 0. If it's balanced, this would actually have a horizontal asymptote of 9 over 1. So since it's degree 4 over degree 4, it is balanced. And so we can say the limit is 9. The limit is 9. And even though we didn't take any time to sketch the graph, we can tell that at infinity, the horizontal asymptote is y equals 9. So we say, and the graph has a horizontal asymptote at y equals 9. You can't say at 9, it's got to be y equals 9. Now, for the sake of complete notes, I'm going to fill in this last page for you, page 6, and just post that online so you have it as examples to look at. But we have till 27. 4 goes till on a Tuesday. It goes. Oh, we do have one more. Goes to 27. Let's use that minute. The one I think that would be the ones I think would be most valuable to look at here is on number 6. This is like a piecewise function. There's 2 pieces, but don't take the time to sketch the graph. Take the limit from the left, which is 7 plus 5 or 12. So the limit from the left is 12. The limit from the right is 14. So this is like one of those, there's a jump in the graph. You can tell it's going from 712 to 7, 14. So here we say the limit does not exist. And it's one of those jumps. And the graph has a jump from 7, 12 to 7, 14. Does that make sense? That you can see the jump without sketching the graph of the jump. Okay, I'll fill in this last column for you and post the notes online. So the homework is homework H1.2. It's due tomorrow. The solutions are online. Enjoy that. Good job today. You are doing great.
Come to the front office.